Solving trigonometric equations, worksheet 3 solutions. Solve for x in the interval of 0 to 360 degrees or 0 to 2 pi. The equation before us is 4 sin x tan x minus 3 tan x plus 20 sin x minus 15 equals to 0. I hope you got this. If not, then look into this solution and my suggestions. Now, this is kind of a complicated equation, and what you can see here is probably factoring out tan x here may help us. So we'll factor this like groups, right? So we'll form two groups. One is this group for us and the other one is that. So it's factoring by grouping, right? So here what is common? Tan x is common. So we'll write tan x, take out, and we are left with 4 sin x minus 3 tan x. And here number 5 is common, right? So we can take 5 common and we get 4 sin x. 4 sin, oh sorry, it was just 3, sorry, tan x I took common, minus 3, right? And it's a good check. You should get same factors both places, right? If not, check your result. There's something wrong. Yes, we did take tan x common, so that was factored out. We are left with 3. So now we have 4 sin x minus 3 as a common factor. So we'll write 4 sin x minus 3 and we get tan x from here plus 5 equals to 0. Good. So that gives two possibilities of solution set, right? One is 4 sin x minus 3 equals to 0. The other one is tan x equals to 5 minus 5, I should say. Tan x plus 5 equals to 0. Okay, so let's figure out what result we get from here, because sin x minus 3 equals to 0, that means sin x equals to 3 over 4, right? So let's find possible solutions for this set. Sin x equals to 3 over 4. So sin x should be in which quadrant? Sin x should be in quadrant. It's positive, right? So we are expecting answers in quadrant 1 and 2. So let's use calculator, because 3 over 4 we cannot get from special triangles, right? So we get sine inverse of 3 over 4 equals to 48.6. We'll round it to one decimal place, 48.6. So one answer we got here is x is equals to 48.6, right? Okay, the other one will be 180 minus 48.6, right? So we'll write that 180 minus 48.6, and that is 131.4. So the other solution is 131.4, correct? So these are the two possible solutions for sin x. Okay, let me write again how we got it, right? Because that was also a question from my student. X, sin x equals to 3 over 4, it means x is equals to sine inverse of 3 over 4, right? Then use your calculator and figure out what is sine inverse of 3 over 4. So you'll get 48.58 something rounded to one decimal place, right? So that gives you one solution which is in this quadrant, right? Now you know sine x is positive in quadrant 1 and in quadrant 2. Since our domain is from 0 to 360 degrees, we have to write that solution also, right? So one solution for us is this, which is 48.6. The other one is this, right, which is 131.4 degrees, right? So let me write degrees here for both of them. Correct. Now let's figure out the solutions from tan x plus 5 equals to 0. That means tan x plus 5 equals to 0 means tan x equals to minus 5, right? Tan x equals to minus 5 means that we are in quadrant 2 and 3, right? You remember the CAST rule, C-A-S-T, right? Tan is positive here, but it is negative in quadrant 3 and 4. So we are expecting two answers. So in this case, what we do is, we find related acute angle alpha here. That is not a solution, but alpha we find, which will be positive, right? So we will do tan inverse of 5. So we say tan inverse of 5, right? Don't write minus 5 while calculating. So write tan inverse of 5 and you get an answer 78.7. So we'll do x is equals to tan inverse. I should not write x, let me write alpha. The related acute angle is, so I'm not writing minus here, tan inverse of 5. And I get this as 78.690, which is 78.7 degrees, right? So this is my alpha, right? So what is the value of x? Now I can write the value of x. So the possible values of x is 1 in this quadrant, which is, so let me write this as, so these are two possible values, one here and the other one here, correct? So that one will be 180 minus this value. So let me write like this, 180 degrees minus 78.7, and the other one is 360 degrees minus 78.7 degrees, right? So we get two possible solutions, and let me check them. So it is 180 minus 78.7, which is 101.3, and the other one is 360, or I can add 180 to this, right? Plus 180. Remember, time period for tangent is 180 degrees, right? So we can add 180 here and we get 281.3, correct? So these are two more solutions for our problem, right? And therefore we can write all the possible solutions here. Okay, so we write solutions. It's just a good practice to plug the values back into the equation and check them, right? Now here the solutions are, so our answer I wrote. Our answers are, so we got 2 from here, which is 48.6 degrees, and then we have 131.4 degrees, and then we have 101.3 degrees and 281.3 degrees, right? As an added exercise, I'd like you to plug in all the values in the equation and check which are the real answers, right? I expect them all to be right, but let's see. We don't know, right? You need to check and confirm. Another part of this equation is, I would like you to write a general solution for all this, right? Just as you saw, we got 78.7 degrees, right? In general, if this domain was not given to you, then how will you write this? Correct? So that is a general solution. So you can write that as, so I'll do one of them for you just to give you an idea that how to write these if general solution. Let us say x belongs to real number. In that case, we could have written this answer as, so you got two answers, 78.7 you took out from 180 and you got an answer as 101.3 degrees, right? So you could have written this answer as 101.3 plus n pi, or n times 180 degrees, where n belongs to set of integers, correct? So that means it repeats after every 180 degrees, and that gives me a general solution for x. Do you see that? So that is a way of writing your solution, right? Similarly, figure out a way to write the solution for these two, okay? So you can write for 48.6 using similar kind of a strategy, right? This repeats after 2 pi, and that will repeat also after 2 pi, not pi, not 180. This repeats after 360 degrees, okay? So that is how you should be doing it. Thank you.